Okay, welcome back. This is Chapter 6. You know how the book is kind of organized. It pretty much will follow the OSI model until you get to this chapter. And so they talk about the application layer, and they're not necessarily talking about layer 7 in the OSI model. They're kind of taking the TCP/IP approach, where layer 5, 6, and 7 are all squashed together into a single thing, which is perfectly okay. If you recall the difference between the OSI model, which is clearly a model, and the TCP/IP implementation, which is clearly an implementation, then you kind of understand that their ideas were kind of lofty, but in practicality we just didn't use an awful lot of that. So layer 5 in the TCP/IP model. Okay, fine, whatever. Applications. In the book, they talk about emphasis. They're not talking about every application. Emphasis on web, email, FTP, and a brief flirtation there with instant messaging. So let's turn to page 193 in the book, and let's go over the learning objectives. Dun, dun, dun. So, you're supposed to learn the services provided by the application layer. That sounds pretty easy. Learn a little bit about hypertext transfer protocol. Learn a little about the simple mail transfer protocol. Learn a little bit about file transfer protocol and instant messaging, which is kind of sort of what I just said. Okay, so let's start off with kind of like an overview on page 193. And they talk about the layered approach one more time. Okay, so I've got some sort of physical layer down here. And then some sort of an L2 thing going on, an L3, which is almost always going to be IP, an L4, which in our case most likely is TCP, could be UDP, and then you have a whole host of these applications up here that just feed on top of that layer 4, and that's kind of the way it's designed, so that the applications talk directly to the TCP or UDP. They don't have to worry about packet delivery and timeliness and whether or not you lost a packet. They don't have to, the applications don't have to deal with that at all, because that's somebody else's responsibility further down. And they never really directly talk to, like, the IP layer or the lower layer 2 layers. They don't actually talk to any of those guys. Okay. So it's a matter of abstraction. These guys don't have to know anything at all about how this thing is being implemented. So can HTTP run over an Ethernet cable? Yes. How about a wireless connection? Yes. How about a point-to-point connection? Yes. So, HTTP doesn't care, which is good. Okay. It should be fairly obvious that instead of having, an L2 that talked a bunch of stuff, and L3 that talked to everything, and L4 that kind of spread out, these guys are very, very specific. So, the HTTP protocol is designed to do one thing and one thing only. It is not generic. Okay, like TCP is extraordinarily generic. IP is probably even more generic than that. It'll run on a barbed wire fence. But HTTP, well, it was specifically designed to do one thing and one thing only. Likewise with simple mail transport and file transport and all the rest of these guys. They're individual little silos that are not designed to be generic. Okay. So in that regard, the application layer, or layers, is unique in that two things. First of all, it is not generic. It's very, very, very specific to what the task you're trying to do. Not the implementation part, the task. Is specific to the task, not implementation details and how to get there. And it's the only layer that can talk to the rest of your computer. For example, the IP layer couldn't actually get access to, for example, your hard drive. It just wasn't allowed. The TCP layer couldn't access files on your hard drive. But these guys, they can. Okay, these are the guys who actually can talk to the, get input from the keyboard and the mouse, display things on screen, make sound appear, make videos appear, store things on hard drives. None of the other layers can do that. Okay, let's continue. So, The first one they talk about is the web. On page 195, they talk about, web access. And by the way, the book kind of waxes philosophically about an awful lot of these topics, about saying, it's the greatest thing since sliced bread. And I'm thinking, okay, that's fine, but this is a data communications course, so I'm going to cut some of that and just stick with the part that's relevant to the topic at hand. Okay. There's a side note there in a shaded area, page 196, which is really good. Hint, hint, hint. Like maybe test questions could come from that. That talks about the difference between the lowercase I internet, the uppercase I internet, and the web. Okay? So the lowercase I is a collection of machines. The uppercase I is a collection of machines, all talking IP and all sharing stuff. The web is a subset of that, which is all those machines that are running the HTTP protocol and have web pages and all the rest of that stuff. So clearly the web is smaller than the internet. Cool. All right. There's some history here, but it's probably a little boring. About 1993 is when the commercial use of the internet really kind of picked off, because maybe you don't remember this, but when the internet was first built and the web was going on, you were prohibited. There were no .coms, really. Well, that's not true. You weren't allowed to do business over the internet. It was strictly for researchers and, the defense folks to do stuff back and forth. It really wasn't for Sears and Roebuck having a web portal. That wasn't what it was designed for. So about in the early 90s is when that kind of turned around, and so everyone kind of went nuts, as you can imagine. Tim Berners-Lee in 1990 created the very first web browser. He did more than just the browser. He took some technology that already existed. There had always been a way to mark up text, and these things are typically called markup languages. So if I told you there was a hypertext markup language, then you know that that's a type of markup language. Okay. He took an existing thing that it was existing. That made no sense whatsoever. He took an existing framework and said, let's take that and let's tweak it a little bit and make that accessible over the internet. So what he basically did is he created the HTTP protocol, established this protocol for sending pages back and forth. He kind of formalized the HTML language, because the original markup language, it's called the SGML, is huge and very complex. And he basically threw away like 2/3 of it and just said, look, all we're interested in is this tiny little piece of this gargantuan standard. He just trimmed it down to the pieces that he wanted. And then he created the whole concept of a URL. So that was his three things that he did. He helped do the HTTP protocol, helped trim down the markup language to something a little more meaningful, and he kind of established this URL concept. Okay, so right off the bat, before we even get any further, what's the difference between HTTP and HTML? Okay, well, HTTP is a hypertext transport protocol. It's an honest-to-God protocol for getting pages from point A to point B. A hypertext markup language is something you do inside Notepad, where I use angle brackets and these goofy little tags to tell you that I want this text to be in bold or italics, or I want a bullet list or whatever. So one is a markup language like word processing. So does word processing have any resemblance whatsoever to transferring files over the internet? They are not related in any way, other than they're used in conjunction to create web pages. Okay. Again, there's an awful lot of stuff in the book here about, the web is wonderful, blah, 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 blah. Okay, whatever, dude. Let's move on. One of the things that is kind of interesting is just how big is the internet? That's actually a pretty decent question. There's some companies out there that do this kind of data mining. Here's a company called NetGraph, and they kind of do data mining for a living. And what they basically have said is there's about 200 million active websites on the planet today. That's an awful lot. Now, there's an awful lot more domain names that have been set aside, but there's no web presence there. There's no traffic going to them. So the number of active sites is somewhere around 200 million. So 200 million places where you could go in the web. That might be a little tough to do in an afternoon, huh? Okay. So another question is, where are those websites? And not surprising, they're in the developed world. Okay, so here's a map showing the density of websites. And they're mostly in the US and they're mostly in Europe, Pacific Rim. So Pacific Rim, India shows up, a little bit of Brazil, but all the rest, I mean, that's where websites are. Okay. Let's go back to HTML. So on page 199, they actually talk about it. So what the heck is a markup language? Well, a markup language is just like a word processing. It's like, I have this sentence here and I want it to be in bold. How do I do that? How do I mark up the text, like in Notepad, to make something bold? And quite frankly, it's just about the way you'd expect. I mean, you say, I go here and I say, you know, Mary had a little lamb. And I want the word little to be in italics or bold. So let's just do bold. So a markup language means I use these little tags in here. I use a B tag to turn on the bold. And then I use a /B to turn off the bold. If I wanted this in a paragraph, I would start a paragraph with a P, and I would end the paragraph with a /P. They're just tags. This is Notepad, okay? Nothing fancy here. It's just text. So I take plain old everyday text, and I mark it up to make paragraphs and bolds and bullets and all the rest of these things. That's what a markup language does. Now, specifically, this particular markup language is really about how do I get hyperlinks, because that's really the key thing. I mean, who cares if it's bold or not if I can't go to a website and then go launch something else, go to a different page. And so there's a thing called an A tag, an anchor tag. I don't know why it's called anchor, but an A tag that's got something, 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 and it has in here a way to get to some other location. So I put in whatever the heck I want, HTTP www.kumquat.com, and then some sort of button that says push me, and then I close off the A tag. So this is a special type of tag. Instead of marking up just for visual cues, this is a tag that actually has some smarts behind it, so that when I click on it, it knows to stop that page I'm on and go launch this other page. And that's essentially it. They show an example, which is probably a little better than mine. And so here's their example. And most web pages follow this format. There's an HTML tag at the top, there's a head tag, and inside the head tag is probably a title. And then there's a body tag, and then there's a heading tag, and then there's blah, 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 blah. And, I'm not going to be asking you to tell me what these tags are, because we have an entire 315 course. If you ever want to learn how to do web design, go take the 315 course, and you learn that. So what I'm trying to get to is, this is text, just plain old everyday text using these goofy little things called tags, which sometimes are used to kind of mark up the page for visual reasons, and sometimes they're used for launching links to other locations. Okay, this is a good place to stop for the 15-minute mark. We'll pick this thing up again in just a few.